Hi, my name is İrem Selcen and I'm an electrical and electronics engineering student at Bilkent University, and today I'm going to talk about my Physics 102 project. In this project, I aim to observe the factors that affect the induced voltage on a coil when a magnet is dropped into it. And this was my experimental setup. I attached the coil to a cardboard and used a multimeter to measure the induced voltage when the magnet is dropped. Now let me talk a little bit about the theoretical background of my experiment for a better understanding. I came to the idea of this experiment based on Faraday's law of electromagnetic induction. He suggested that the interaction between a magnetic field and an electric circuit results in the generation of electromotive force. Then Faraday showed that EMF induced on a coil is proportional to the negative change in the magnetic flux. And since each turn on a coil experiences the same magnetic flux, for a coil made of n turns, EMF is proportional to the number of turns. For my experiment, firstly, I used 4 different coils with 5, 15, 20, and 25 turns to observe the impact of the turns on the induced EMF while keeping the height constant at 23 centimeters. These are some clips that I took while I was doing the experiment. I intended to keep the change in the magnetic flux constant by keeping the height constant. However, due to air friction, the attraction between crocodile cables and the magnet, and the initial acceleration of the magnet, the measured EMF showed inconsistency, and I had to do multiple tries and take the average of the results for a better comparison. These are the results that I obtained for every coil. This is for the coil with 25 turns, 20 turns, 15 turns, and lastly 5 turns. Then I plotted the graph with the results that I've obtained and drew the best line to show the relation between the number of turns and the induced EMF. Then for the second part of my experiment, I kept the turns of the coil constant at 15 and changed the height at which the magnet is dropped to 28 and 33 from 23. After obtaining the results, I again plotted the graph to illustrate the relationship between the rate of change of the magnetic flux and induced EMF. And these are the results and the graph. This is when the height is 28 centimeters. And this is when the height is 33 centimeters. And finally, I was able to show that the induced EMF on a coil is proportional to the number of turns and the rate of change of the magnetic flux. Thank you for watching.